Okay, so for number 32, we want to see whether the series is convergent or divergent. So what we're going to do here is we're going to break it down into two different series because we do have this to the power of n. So this does look like a geometric series. So what we're going to do here is we're going to take this, so from 1 to infinity, and we're going to split this up into two parts because we have a single denominator. So it's going to be 1 over 2 to the power of n, and then plus, from 1 to infinity, it's going to be 3 to the power of n over 2 to the power of n. And now I do want to focus specifically on this one. So this one here goes from 1 to infinity, and 3 to the power of n over 2 to the power of n can be rewritten like this. Now, a geometric series of the form from 0 to infinity of a r to the power of n is only convergent if the absolute value of the ratio, so the thing that is being raised, is less than 1. The reason is, as we're adding these terms infinitely, we need the terms to eventually go to 0, because then you'll essentially just be adding 0, and that means that your total sum won't change. But in this case, because our ratio is 1.5, as n gets larger and larger and larger, our number, say 1.5 to the power of a million, that's going to be huge. So with every term that we add, our sum is just going to get bigger and bigger and bigger, and it's not going to converge. So this one here already fails the divergence, test. So it does diverge. Now, it does not matter if this one here converges, because if one part of it diverges, then the whole thing is going to diverge either way. So we can already tell here that number 32 is going to be divergent.